Okay, good morning. We'll wait for 2 to 3 minutes, then we'll start about the lab part. Okay, we will be unable to go to lab because of the network connectivity, but we'll try to. I have some recordings with me. I will be taking you through that recordings, and we'll try to cover up all the left portions. Okay, we'll focus on more on the lab part, understanding part, and then we'll go into the scenarios. Okay. This experiment, why we directly I came into the distance relay. Okay, because this experiment is totally based on the distance relay with electromagnetic or electrostatic uh, type of relay, and the another one is numerical relay. But numerical relay we are not going to see. We're going to see about the distance relay. So this experiment shows about the zones, about the distance relay functionality, what type of uh, fault will be occurring at what particular zone. So entire segment is that. So I thought before that let's discuss about what is the different kind of relays. Okay, so we focus on the distance relay. So what is actually a distance relay? Okay, a distance relay uh, is a fundamental device, okay, that trips the circuit breaker in the event of a fault. Okay, this is a protection relay. You know the working of the relay. Okay, so it is a fundamental relay that devices that trips the circuit breaker in the event of a fault. Okay, in a low rating power system circuit, okay, the relay itself can trip the circuit without the circuit breaker. Okay, in very low ratings of the power system. Okay, so the relay along with the circuit breaker together are used for the protecting device. Okay, protection of as a used as a protection device for any particular, like if we talk about transmission or distribution system or. Okay, so in this both, okay, the relay and with the circuit breaker, both used as a protection devices for the transmission and distribution system. Okay, so now, so relays are generally classified, okay, totally based on the principle of working. Okay, what is the principle of operation or working, whatever you call. Okay, I've been totally been classified, okay, based on the principle of working. Okay, so we have a different kind of relays. We have overcurrent relays. Okay, we have differential relay that is normally used in transformer protections. Okay, we have frequency relay. We have like we also okay, this distance relay is also there. Okay, for which the operating quantity is correct. Okay, in differential relay, worker relay is obviously the operating quantity is current. Okay, that's why we use CT with that circuit profile. We use CT in that, right? So okay, so based on the operating quantity, the pickup quantity is calculated. Means that which is to be used. Okay, and June has been classified. So alter different kind of segment are used. Okay, so let's talk about this distance relay. So in this distance relay, so the operating quantity is your impedance of a transmission line or impedance of the distribution line. Okay, or independent impedance of your system. So based on the impedance of the if we go for the transmission line protection. Okay, so based on the impedance of the transmission line, the relay will operate. Okay, or the relay operates. So how it works? Okay, the impedance of a transmission line is calculated based on the fault which it has been, okay, where the fault is occur, and the fault locations, okay, and voltage of the time and the fault current all are being calculated. Okay, so this resistance relay is also being classified into more two types. Okay, first is your impedance, okay, so the another two is classified, okay, that is uh, that was classified as a Moore relay and the reactance relay. Okay, based on the distance of the protection or based on the span on the transmission line. Okay, these were classified. Okay, now, so if someone asks you that what is the distance relay, actually you have to define what is the distance relay. Okay, so how you will be answering that? You could answer like uh, your distance relay, okay, are the protecting equipment. Okay, first of all, that it will be uh, told in a shorter way. I would try to enclose this in a shorter way. Okay, so what is a distance relay? Distance relay is a protecting equipment, okay, that functions based on distance of the fault point on the transmission line. Okay, so we work on the distance of the fault point on the transmission line. Okay, now, so the distance is calculated from the generating unit. Okay, so the distance is calculated from the generating unit. Okay, so based on the distance, okay, the impedance is calculated by evaluating the fault voltage and fault current. Okay, so this is your terminology. Okay, so distance, what is a distance relay? Distance is anything but it is a protecting device. Okay, it is a protecting equipment or protecting device. Okay, that functions based on the uh, distance on the distance of the fault on the transmission line, and that distance is measured in the form of impedance. It's not the length, it's not the kilometer, it is totally on the impedance, okay, of the distance is calculated and the based on the impedance. Okay, so the distance is calculated from the generating unit. Okay, so based on the distance, the impedance is calculated by relating the fault voltage and the fault current. So this is the segment about if one asks you what is your distance relay, then this you could answer it. Okay. Now, if you want to learn a few more thing about this mm, distance relay theory and also I could tell you about the drawbacks and all. Okay, the actually this distance relay. Okay, the major necessity of uh, or you could say the why it is required. Okay, so the requirement of the distance relay has occurred. Okay, because there is few drawbacks in the other relays like overcurrent relays. Okay, so you could find somewhere in the books or segment. Okay, so because of the drawbacks of the overcurrent and uh, over voltage relay. Okay, these uh, distance relay were required. Okay, it was very necessary, a major necessary segment to have this distance relay. Okay, so actually why it is got because the main concept, okay, the very main concept is totally depending on the type of fault. Okay, okay, that how the distance protection can be provided with small changes. Okay, like if I for instance I give an example. Okay, the reach of the line. Okay, to your line to ground fault. Okay, the reach to the line to the ground fault is very much less than the reach of the three-phase line. Okay, so if we desire to provide a uh, protection up to a certain point, okay, we need to adjust the pickup point of overcurrent relays. Okay, this is not possible since the relays are designed for one value of pickup current. Okay, only for one value of pickup current. Okay, you know the settings and all, and that you'll study more on detail. Okay, so this one value pickup current is a major or the biggest disadvantage of overcurrent relay in the fault current. Okay, it depends on the type of fault. Okay, therefore the length of the line it is protected depends on the type of totally false. Okay, and whereas it talk about your distance relay. Okay, so the distance of protection is also varied. Okay, on the source impedance. Okay, so the lesser is the source impedance. Okay, the more is the distance covered for any particular type of fault. Okay, so this is why the distance for which the overcurrent relay protects the line depends on the source impedance also. Okay, okay, so I would uh, wrap up it fast and we'll move into that segment. Okay, let's me draw one basic diagram of your distance relay. Okay, if I could draw it. Okay, so let's see if I have one. Mm, okay, I just forgot my this, so it will be a bit hazy because I'm drawing with the help of hand. So measurement has been not as. Let me check once if I have the same thing. Okay. Okay. So this is your one. This is your resisting coil. This is your operating coil. Okay. So this is your relay. Okay, here we measure your VT and where we measure your IT, and this is your Z. Okay, so this is your Z, right? So based on this, this is your type. Okay, now, so this following figure is totally your the structure of a distance operating principle. Okay, as shown over here, it starts with the source of electrical, that is alternator. Okay, then we measure the current. Okay, through a current transformer. Over here we measure through the current transformer is used in series with line. Okay, similarly a potential transformer is used parallel with your transmission line. Okay, to measure the stepped down voltages. Okay, so these two parameters are fed to the relay for evaluating the impedance of the transmission line. Okay, then the relay is connected to the circuit breaker. Over here you could write, okay, two trip. Okay, so it is then connected to the circuit breaker as shown. Okay, where when your so when the relay operates, it sends the tripping signal to the circuit breaker, which immediately break and isolate this faulty line. Okay, this isolate this faulty line from the alternator. Okay, so, as shown in this figure, this ZF is the fault impedance. So the impedance is assumed to strike at the end of the transmission line. Okay, so this is the segment. Okay, now if we talk about the characteristics, okay, we talk about the characteristics, okay, of your distance relay. Okay, so the characteristics, okay, of this distance relay, okay, it can be explained with the help of your RX diagram. Okay, it could be easily explained with the help of the RX diagram. Okay, in which the impedance of this transmission line, okay, is represented by the radius of the circle. Okay, where the impedance of the transmission uh, line is represented by the radius of the circle. Okay, so let's draw. If I could draw a good circle. Okay, so so what I told you, the radius of the transmission line is represented by the radius of the circle. So as in this, we could consider the radius of the circle is your Z. Okay, as shown over here, the radius of the circle is Z. Okay, so the phase angle between R and X, this is your minus R, this is your R minus X, and this RX diagram. So the phase angle between this R and X, or also called an impedance angle, okay, that is your this that is your this phi. Okay, so also called the impedance angle, okay, to represent the position of the vector theta, okay, as shown in over here, okay. So the characteristics of consists of two axes, okay. One we have r and one we have your x-axis, okay. So now in this diagram will position will show about the where which is your operating unit and which is uh, 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 non-operating unit, okay. So we could also show that uh, that your operations, okay, operations can be explained in four quadrants, right? We have 1, 2, 3, 4, so we have four quadrants. Could be explained in the, will not try to explain in the four quadrants, okay. When that is your r is positive, okay, x is positive, okay. When r is positive and x is positive, okay, which means the fault impedance is greater than the normal impedance, okay. So in these two cases, the r is positive and x is positive means the fault impedance is greater than the normal impedance. Hence, okay, there's the relay operate in the second quadrant, okay. So in this second quadrant, okay. Relay operate in the second quadrant, okay. In this, the angle is negative, okay. In this, your theta is negative, okay, angle is negative, therefore the relay will not operate. Similarly, in the third quadrant, the relay will operate, okay. So in the second quadrant, over here in first quadrant, okay, we were talking about this quadrants. So let's see. So we talked in the first quadrant, r is positive, x is positive, okay, r is positive, x is positive, okay, the fault impedance is greater than the normal impedance, okay. So hence the relay will operate in this part, okay. Now in the second quadrant, okay, the angle is negative, means this one of the angle is negative, minus theta is negative, okay. So therefore the relay will not operate in this region, okay. Similarly, in the third quadrant, the relay will operate as both are in negative, okay. R is also negative and this is negative, okay. Now, so in this, in the region, okay, where the relay will not operate, okay, the restoring torque, okay, that is your restoring torque, okay, is greater than the deflecting torque, and in the operating region the deflecting torque is greater than the restoring torque, okay. The distance are applied in the short, medium and long transmission type of relay, okay. So this is the characteristics. Now we talk about the types, okay, where we have okay, that is your reactance relay, okay. So in this type, okay, this is of this kind, this is your r, this is your x, this is your 0, okay. In this, the x-axis is parallel to your r-axis, okay. Your x, that will be k dash by k, okay. So this type of relay will not operate for the resistance of the line. It will operate uh, only for the reactance, this type of relay will operate for the only for the reactance, not for the resistance. Okay, so the what are the advantage of this? Okay, advantage will be it respond to arc. Okay, could not could be used for small or short lines. Okay, okay, small transmission line. Okay, it will be used for small, and it is fast sensing. Okay, fast fault sensing. Can be able to this. Okay, now the disadvantage is now again a factor to this. Okay, cannot be used for locating relay. Okay, in this first is cannot locate the fault. Okay, second it will not be able to distinguish between the fault in our station and other stations. Okay, and it is not suitable for long transmission line. Okay, this is the advantage, as it is for a short transmission line, so not suitable for long transmission line. Okay, the second is your impedance relay. Okay, that we showed now. This it can be represented in this. Okay, operating zone, non-operating zone. Advantages in addition of the directional element can be used for better performance. Okay, now the another and the next terminology is your mode relay. Okay, or you could also call it as admittance relay. Okay, whose characteristics look like this. It will be like this somewhat. This part. Okay, it will be looking like a this, and this is your Z line. Okay, so advantage is the fault area is well defined. Okay, it is a directional, so it can be designed to operate for a particular site. Okay, it is a directional, so it could be A. Now it can be used for long transmission line. Okay, it responds to both the resistive fault and reactive fault. Is good, that is was not there in your reactance relay. Okay, and the disadvantage is it cannot be used for small transmission line. So no issues. We have reactance relay in this. For this, it is there. Okay. So these were the thing that you wanna see right now, and we have seen ties. We have learned. We will study this in more in detail. Okay. So you will go through with the larger portions. Okay. So I will play a video. Okay. Meanwhile, you could seek all those things about what I have explained in that particular manner, and we'll try to get more of the stuffs from this. Okay, so and if you get it get breaks, so you could rejoin and we could start over from the same thing. Okay, same video and same thing, wherever it is required. Okay, so we could easily see and we could easily study about all the contents whatever we have with us. Okay. So no issue in that, we could easily catch up the things. Okay, so if anyone is having any doubt you may ask, because I think so we have only 1 minute left. It will video would be ending, so we'll start that recordings part in next video. Okay, next joining. If anyone is having any doubt you may ask. We have talked about all the things. Okay, so you could know the characteristics. Okay, this is your reactance one, this is your impedance. Okay, and this is okay. So this is a direction one. See, in this particular form it's not there, so it is a directional kind of relay. That is your move, this is your impedance, relay, and this is your reactance. Okay, only use, not used for resistance, only used for reactance. Okay, it is used for both reactance and this. Okay, and this is your distance where then this quadrant will not operate. This is your z. Okay, it has a limitation, boundage is bounded, this is the operational unit, and this is your non-operating unit. Okay, so these are the three different characteristics. Okay, so let's rejoin this.